Okay, so we have seen the division of exponential expressions that have like signs. Okay, so now we're going to be dividing exponential expressions with like bases, but their exponential expressions may be different, or in this case they will be different for this purpose of this video. So by the time you finish with this video, you should be able to divide exponential expressions that have different, that they do have same base, but they have different signs on their powers. Okay, what do we mean by that? Well, let's start jump into our first problem. So consider that we have x to the fifth divided by x to the negative fourth. The rule of division of exponential expression says that if the bases are the same, we'll keep the base and simply subtract the denominator power from the numerator power, which is m minus n in this case. Right, so we do that for this one here. Let me try use blue pen so you can differentiate a little bit. So the bases are the same, so we'll keep the base and say x and 5 take away negative 4, not just 5 minus 4. That's not what the rule says. It says take away or subtract the denominator power from the numerator power, and when you take away this or subtract this, you need to put that minus this sign here. All right, so don't make that common mistake here that they forget the minus, or they relate that this negative sign and this minus is the same sign. It's not. So we bring them to the next step now, and we put here x, and we follow the rules again. X 5, and this minus and this negative makes it positive, which then gives us x to the 9 power as our solution. So that's our solution to this problem here. So notice what we did here. We said x to the fifth divided by x to the negative fourth. We got x to the ninth. Now some of you may be wondering, but how come, if we're dividing, how come the number went up? Well, what happens is that this is at the bottom, which is a negative sign, but for right now all you need to worry is that subtract this second power, because when we reach the fractional powers and the fractional bases, then you will see how they're all really related and how they come about in that part. Okay, so we proceed. So the next problem that we are going to be working with is as follows. We have 2x to the 1/2 divided by x to the 1/2. Well, these are positive powers, so the rule says we'll keep the base and take the first power, subtract the second power, which is then equals to x half, take away what half will give us 0, and so our solution will be x to the 0 power. This is not wrong, but it's simply incomplete. Anything to a 0 power is always equals to 1. So let me put this rule right away. Any base to a 0 power is always equals to 1. Need to remember this piece here. Okay, so that's what we mean by that one there. Let's proceed with the next one. Now consider that we have problems where the powers, okay, the powers are fractions, but they're unlike denominators on their fractions. So we have x to the 1/2 divided by x to the negative 1/3 or positive 1/3. See then what happens. Well, the rule says that if the bases are the same, we'll keep the base. So let's keep the base. Right, and then we'll take the first power, the numerator power, take away the denominator power. Okay, so that's what we did here. We're taking it away. Let me zoom a little bit more in there. So right there. Now, because the working here will be jumbled up, you can do this working on the side, and that is acceptable. You have 1/2 take away 1/3. Go back to the rules of subtracting two fractions. So 1/2 take away 1/3. We look at the LCM, which is in this case is 6, and we say 6 divided by 2, 3 times 1, 3. 6 divided by 3, 2 times 1, 2, which then gives us 1/6. Therefore our power here will be 1/6. Imagine doing all this work on this little space here. it makes your work looks dirty, and teacher may not want to check it, or they may get confused. So this is what you do: bring this working on the side, working on the side, and then bring the solution to this part. Remember, we are not adding the BS's or subtracting the BS's. It is the powers that is being added or subtracted. Let's try now one where we have a mixed number. So if we are working a BS, 1/5 divided by x to the 1.5 equals, what do we do now? Well, the rule doesn't change again. We'll keep the base and say 1/5 take away 1.5. Go back again and do your working of the powers on the side. We have 1/5 take away 1.5. Okay, so we can convert this mixed number to an improper fraction, which is the best approach. For right now, 1/2, I put minus 2 times 1, 2, and 1, 3 over 2. What's the LCM of 5 and 2? That is 10. 10 divided by 5, 2 times 1, 2. 10 divided by 2, 5 times 1, 15. Okay, which now gives us 2 take away 15, negative 13 over 10. You may leave it as an improper fraction, or you may express it negative 1 and 3/10. So now we bring only the solution, the one that you choose here, and you put here x to a negative 13 over 10. This makes your work look much neater compared to putting all this work in this little space here. Okay, so we can proceed. Now that was when we had it as positive power. What happens when this is negative power? Let's see. Let's do that same problem, but instead of having positive power here, we will be making it a negative power, x to the negative 1.5. Okay, the rule doesn't change again. You keep the base and you will subtract their powers. Notice how I did the subtraction of the second power. I put it in brackets. It is recommended. So you put now here on the side 1/2 take away, no, 1/5 take away negative 1.5. Okay, since both of them are negative, that becomes positive automatically. So this is 1/5 plus 1.5. All right, now convert that mixed number to an improper fraction. You end up with 1/5 plus 3 over 2. How 3 over 2? From here we've already done that. And then look at the LCM, which is 10, and 10 divided by 5, 2 times 1, 2. 10 divided by 2, 5 times 3, 15, which then gives us 17 over 10, or 1 and 7/10. Either it is still correct. So now you come back here now and you put x and put the solution 17 over 10, and that's our solution to that problem there. So instead of writing all this working here, do it on the side and then just bring the solution to that part of the problem that we are working with. Okay, now let's try one where we have a combination. Okay, so now we're going to be dividing, and we have to be careful when we divide. So consider that we have a problem, and this was problem number 5. Problem number 6 now. A bs x to the 5th y to the 8th divided by x to the 3rd y to the 10th. Okay, let me make that tree a little bit better there. So the rule doesn't change again. It says that a bs to a power divided by that same bs to different power. We'll keep the bs and subtract the numerator power from the denominator power. Okay, but in this case we have more than one bases, right? So what do you do is that you will work the bases with their respective bases. So we come here and say now x to the 5th, okay, x to the 3rd, but it says subtract the power, so put minus 3, and then the y will be 8 take away 10, okay, which is then now x to the 2nd, y to negative 2. Leave it as that for right now, okay, because this is the rule for the meantime. This piece here will need to be able to express it in a different form. For right now, leave it as this. Okay, no need to proceed any further than that. As we are going BS, the rules of BS is one at a time. So let's start. We'll go with the next one. We have now 8x to the 5th y to the 3rd divided by 4x 2 y 1. Okay, so that's our problem. This says 8x to the 5th y to the 3rd divided by 4x to the 2nd y to the 1st. Well, numbers with numbers, so we're going to say 8 divided by 4, which is, so 8 divided by 4, you can put it here if you want, or you may express this slightly different if you want, but just remember, in this case we're just working with the BSS. So 8 divided by 4 will give us 2, and then x to the 5th, take away 2, because this is x to the 5th, x to the 2nd, y to the 3rd, take away, divided by y to the 1st, which means subtract the first power, giving us now 2x to the 3rd, y to the 2nd, and that's our solution for that one there. Okay, so notice it's not difficult, just have to work piece by piece. Leave your powers of your solution into a negative for the meantime. Leave it as this. Okay, so for right now, just leave the solution this way, unless you're told to specify your solution a particular type of power, then yes, we need to do some changes, but that will come afterwards. All right, so we're taking piece by piece on the laws of indices.